Hey guys, Mrs. Dan's here. So you should have gotten your book out of your mailbox. We're on the first lesson of our new unit, and today we will be talking about the slope of a line. Today you'll be able to find the slope given certain information, and we will see that slope really relates to the slant of the line. Now this honestly should feel like review from what you did last year in 7th grade Accelerated. If not, though, pay close attention. You could always rewatch the video on your own if necessary. This is a very important fact in order to move forward in this unit. So if you could write down the objective and start your do now. Of course, I'm going to be going over the do now as well. Notice on this page, which is posted on your Google Classroom, it tells you what your homework is at the bottom, page 10, and you're doing the odd numbers. So 1, 3, 5, 7, so on. I think it's like a total of 7 or 8 questions, just to practice the skill that we're learning in class today. So the do now asks us which graph is steeper, A or B. So as long as you understand what it means to be steep, you must have picked graph B. B's line is definitely steeper than A's line. Now, in part B, they're asking us to write directions, meaning how many spaces vertically and how many spaces horizontally to move from point 1 to point 2. I'm going to draw on the graph so that you understand even what the question is asking. So I'm just going to pick a color that stands out. We'll use red. And to go from point 1 to point 2, it says how many vertical spaces, meaning how much up do I have to go, and then how much over do I have to go to get from point 1 to point 2. You could see I went up 2 boxes and to the right 4 boxes. So my directions would be go up 2 and to the right 4. And on graph B, you can see that we have to go up 2 and to the right 1. So this actually is what starts introducing us to slope. Slope actually is a ratio. It's a comparison of the vertical distance to the horizontal distance. How much up and how much to the right do you need to go? So we do like to call it the rise over the run. The rise is like how much up we went, and the run is how much over we went. And we like to move over to the right. So how much to the right did we go? My pen is acting a little weird right now. How much up and how much to the right. So if we were to write our directions for graph A as a rise over run, it would be 2 over 4, but all ratios should be simplified, so it's really 1/2. And in graph B, it would be 2 over 1, which is the same thing as 2. If they want it written as a ratio, we do write it as 2 over 1, but we are allowed to also write it as 2. So now in part D here, they're asking which ratio is larger. Is the 1/2 larger or is the 2 larger? And hopefully you know that 2 is larger than 1/2. Think about candy bars. I'd rather have 2 candy bars instead of just 1/2 of a candy bar. So the graph B's ratio is larger. And then they ask us, what do we notice about the comparison of the ratios and the steepness of the line? Well, do you remember we said graph B was steeper, and then graph B had the larger ratio. So really, the larger the ratio, the steeper the line. Very important fact. So we're moving on. If I go too fast, could always hit pause. So now we're going to compare and contrast lines L and K. So line L is going down to the right. Line K is going up to the right. It asks us to find 2 points on each line, darken them in, and then write the directions on how to get from one point to the other. After we write these directions here for line L and line K, they are going to ask us to go write it as a ratio. So I'm going to be honest with you. I'm going to take a shortcut. I'm just going to go straight to writing it as a ratio. You understand how to write the ratio now, right? How much you go up is the top number and how much you go over is the bottom number. So let's go do line L first. It says pick any 2 points on the line. So I'm zoomed in pretty nicely. Maybe I'll zoom in a little bit more just to show you how I'm picking points. I need to pick points that land on the graph paper nicely. So what I just darkened in is a nice point. I would never, don't write this down, I would never use this point right here. It is a point on a line, but it sure doesn't intersect the graph paper very nicely. I want it to be a point so that I can count full boxes. So after this first point that I darkened in, the next nice point, that's what I'm going to use, those are the words I'm going to use, nice point, would be this one. And there's another one here and another one here. You can see actually when I darken in these points, they're all equally spaced. That's because they all have the same rise and run. So I like to do my rise and run as a staircase. I'm just going to go back to the other page for a moment. You don't have to turn back, just look up here. See how I made it look like a step, like on a staircase? I could have like made another step going this way, right? So that it looks like stairs going up the line. I like my slope to look like stairs going on a line. Now, if my line is slanting downward, I make the stairs under the line. That's just how I do it. You are allowed to put them above the line, but I don't know. I get stuck in my habits. And when I'm going down, I put my steps under the line. When I'm going up, I put my steps over the line. But you do want your steps to be equal sizes. Think about a regular staircase. All the steps are equal sizes. If they weren't equal sizes, it would be like a tripping hazard. So this is one box, but it went down. That's very important for me to recognize. One box down and 3 boxes to the right. So in math, we like to think about down as a negative number and up to be a positive number. Right is a positive number, but going left is a negative number. So I know I said I wasn't going to do my directions, but I'm changing my mind. I want to write down that I'm going down 1 and right 3. And this makes me write the fraction -1 over 3. That's my ratio. So my ratio is actually -1 over 3 because the directions were down and right. And I hope that makes sense to you. So now if I do line K, I'm just going to pick a different color. And I darken in some nice points that are equally spaced. Points where I can count full boxes. I can see that I go up 1, right 3, up 1, right 3. I can keep on going. Do I have to draw them all? I really don't. I know that I went up 1 and right 3, which makes me write the ratio 1 over 3. So do you see that the ratios are the same except one of them is positive and the other one's negative? That means that they have the same steepness. The steepness of line L is the same as the steepness of line K. It's just that they're pointing in 2 different directions. So the negative actually tells me direction. It doesn't tell me how steep anything is. They're both the same steepness. It's just that line L is going downward while line K is going upward. An upward slope is positive, a downward slope is negative. And The ratio really is your slope, and slope is rise over run. Now, sometimes we use these words rate of change. We actually use them very often when we're in algebra class. So if I ask you what's the rate of change, it's the rate at which the line is changing. That really means the slope of the line. Now, if I didn't have a line drawn, I could still find the slope. There's actually a formula that we can use to help us find the slope. So let's kind of discover that formula together. So we need 2 points on the line. It says that we want to look at line L, and you get to choose any 2 points. For note purposes, we're going to choose the same 2 points. So let me zoom in again. I'm even going to pick another color now. How about that one? Let's all pick, oh no, this point right here, which is the point -6, 6. I just randomly picked that. And, oh no, we'll pick this one all the way over here, which is +6, 2. You know, I'm hoping you remember from last year and from 6th grade, points are always XY pairs. X comes first, Y comes second. That's why this point over here was -6, 6, because I went to -6 on the x-axis, +6 on the y-axis. And then this point over here was 6, 2, because I did +6 on the x-axis and +2 on the y-axis. Anyway, these are the 2 points that we're going to use to help us find slope. -6, 6, and then 6, 2. Let's write those down. -6, 6, and 6, 2. So remember, the slope of the line really was -1/3. How can these 2 points help us find the slope? Like if I didn't graph it, I'm on purpose not showing the graph. Remember that we're making like a staircase, right? When we moved up or down, remember we followed the y's. And when we moved right to left, remember we followed the x's. So take a look at these y numbers. The difference between 6 and 2, difference meaning 6 minus 2, is 4. And then the difference between -6 and 6, the difference, -6 and 6, means I have to subtract those two, is a -12. What does 4 over -12 simplify to be? Hopefully you said 1 over -3. Hopefully you remember that not just the denominator is negative, really this means the entire fraction is negative, and it's the fraction -1/3. So what did I just do? I just picked 2 points on the line, and then I subtracted the y's, and I subtracted the x's. Slope can be found by subtracting the y's and then subtracting the x's, because it tells us what the rise is and what the run is. I actually do want to go back up to that graph for a second and look at those 2 points and show you the number of boxes in between. So if I drew a big step from one point to the next, using the 2 points I chose, you can see this is 1, 2, 3, 4 boxes over here. I went down 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went over 12. So by subtracting the y's, it's telling me how many boxes are in between going up and down, and by subtracting the x's, I'm finding out how many boxes are in between from x to x, and then all fractions should be simplified. So no matter what points I pick on this line, I'll always get the same slope. Sometimes the ratio will have to be simplified in order to get the correct answer. So the final answer is that negative 1/3. And I found it by subtracting the y's and subtracting the x's, which is the same thing as rise over run. And then some people give this a formula then. They say, let's do y2 minus y1. I'm writing them down really low, right? I'm not writing them as exponents. Over x2 minus x1. And then some people ask me, Ms. Stans, I don't get it. What's that 1 and what's that 2? Well, it's just because we had two different points. Let's go back up to these points for a second. You agree that this is an x and this is a y? Hopefully you said yes. And you agree that this is an x and this is a y? So how do I show how to subtract the y's? That if I have a y next to both of them, someone will say, well, what y are you talking about? I don't know what y you're talking about. So a lot of times we call this first point the x1 and y1, and then the second point the x2 and y2. Honestly, it doesn't matter which one's the x1, y1, x2, y2, just as long as everything in this point both have the same thing. They're both the ones, and everything over here are both the twos. And honestly, it doesn't matter the order that you subtract. I'm going to prove it to you because I'm going to subtract now in the other order. So here, I did the 6 minus the 2. What if I decided to do 2 minus 6 first? Well, if I do this 2 minus the 6, I did the y2 minus the y1. I have to do the same order in the denominator. So then I have to do the x2 minus the x1. So I'd have to do 6 minus negative 6. And now, if I calculate this, I get a negative 4 in the numerator. Don't forget that minus negative really turns into plus, right? Plus positive. So now I get negative 4 over 12, which still is negative 1/3. So what I just did for you was the entire lesson, actually, that you can count slope by picking nice points on the line and making a staircase and counting your rise over run. And just remembering when the line goes downward, it's negative. When it goes upward, it's positive. But what if we don't have a graph? What if we don't have lines to count rise and run? You can now use what we call the slope formula. y2 minus y1 over x2 minus x1 will give you the ratio that stands for the slope. Remember, slope tells you how steep a line is. The larger the number, like in the do now, the steeper the line. And what else did we learn? When it's a negative number, the line slants downward, and when it's a positive number, the line slants upward. That really is the entire lesson. We'll do a few problems to practice, and then you'll be able to start your homework. So, if we were to practice on this page, graph A, I like to pick points instead of use the formula. And I could say I go down 3 to the right 2. Sometimes I'm not confident in myself that I picked great points, so I make sure I can make more than one step using the same directions. Down 3, right 2, and it does work. Right? If you can get back on the line both times, then you did a good job. So the slope would be negative 3 over 2. We don't write slope as a mixed number ever. Slope is a ratio, and a ratio has a numerator and a denominator. Never a mixed number, and we don't like to write it as a decimal either. Is there equivalent forms of this? Yes, but we prefer a ratio. When we look at graph B, since I can't really count boxes, now I'm going to use the slope formula. So again, here it reminds you what the slope formula is. There's something else I want to remind you of from 7th grade. I'm sure you learned that we like to use the letter M for slope. So I could say I want to use the formula, and I write it down. M equals y2 minus y1 over x2 minus x1. To be really clear with you, I'm going to choose these two to be my x1, y1. That's what I choose. Remember, I told you it doesn't matter. I proved it to you before. Just as long as we go in the same order, it won't matter in the end, you get the same answer. So if I follow this formula using the points that I picked, I will do 8 minus 6 over 10 minus 6. So that would be 2 over 4, which is 1/2. The slope is a half. If I go too fast, you just hit pause. Graph C. So important. Oh my gosh. So if I were to count, do you agree, like from this point to this point, I'm counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going up 10, but over nothing? What the heck is 10 divided by 0? Here's my handy dandy calculator. So if you don't know what 10 divided by 0 is, you could test it out. 10 divided by 0 equals, oh my gosh, an error message? What is that? Really, you can't divide by 0. I think you've learned that, and some people then get confused when 0 is in the numerator. 0 is allowed to be in the numerator, 0 is not allowed to be in the denominator. If you have a 0 in the denominator, it means you're dividing by 0. Oh, what did I just write here? I wrote 0. That's wrong. Sorry. Error. I wasn't thinking. It is not 0. 10 divided by 0 is an error message. So we don't write error for like the answer to the slope of this. We actually say it's undefined. So let me go back to what I was saying. When you have 0 in a denominator, you're not allowed to divide. You get an error on your calculator, a divide by 0 error. Cannot divide by 0. You cannot divide by 0. It's like impossible. And when I see you next, I'll even show you physically why it's impossible. But right now, when you get the error message, your calculator's right. You can't divide by 0. So we say that the slope is undefined. But then we look at graph D, and then some people want to say it's undefined. Well, it can't be if you think logically, because in graph C, do you agree that this is a vertical line? And in graph D, do you agree that this is a horizontal line? So they can't have the same slope then, right? Because didn't we just say that slope is related to the slant of the line? So both these lines can't have the same slope because they're not slanting the same way. One of them is vertical, one of them is horizontal. All vertical lines have an undefined slope. That's a true statement. All vertical lines have a slope that we say is undefined. So let's pick 2 points. Let's pick this and this. And let's count. How much up? Oh, I don't go up at all. How much to the right? Oh, I could go just one spot. What is 0 divided by 1? 0 divided by 1 is 0. So I'll get out that calculator again. And if I do 0 divided by 1, I do get 0. I don't get an error message, right? So you can't divide by 0, but you can start with 0. Anytime you start with 0 and divide it, you're still just going to have 0. Division really is a physical thing that you do. If you have no objects and you divide them into equal groups, guess what? You'll still have no objects in any of those groups. So really, 0 divided by 1 is 0. I could use the slope formula for both of these too. If on graph C, I use the slope formula. If I call this x1 and y1, and this x2 and y2, when I do the slope formula of y2 minus y1 over x2 minus x1, I would say -5 minus 5 over -4 minus -4. Well, in the numerator, -5 minus 5 is really -10. In the denominator, -4 minus a -4, it's like keep, change, I get a 0. So honestly, I do get an undefined here. I get a 0 in the denominator, which is undefined. And I could do the slope formula on graph D, and guess what? You would get a 0 slope. I do want to get to graph E and F, because notice the scales on here. Do you see it starts at 0, and then right here it's at 10,000, right? So the scale doesn't go by ones. Therefore, you can't count boxes. You can't count boxes. Be careful with counting boxes. Each box doesn't stand for one. Okay, so you have to be super, super, super careful. If I pick this point and this point, if I were to count, it's not just the number of boxes. I have to go by my scale over here if I were to count. So I'm definitely going downward, so it's definitely negative. How much am I going downward? Well, don't count your boxes. Look at your scale. I went from 50,000 to 30,000. Didn't I go down 20,000? And then if I were to count this, don't count your boxes, take a look at your scale. If I started here and went over to here, aren't I going over 200? So have to be so careful when you scale. It does not go by ones. When scale doesn't go by one, be very careful. Okay, don't just count boxes. You have to look at the scale to see what each box represents. So I went down 20,000 and over 200, and that really should be simplified. Do you know that your calculator simplifies fractions for you? So remember, we do alpha y equals enter for a fraction. So if I enter negative 20,000 over 200 and hit enter, it just simplified it for me. It's equal to negative 100 over 1. I don't really have to put that over 1. So the slope is negative 100. It is going downward, so it makes sense that it's negative. Let's take a look at graph E, the price of apples. If we pick this point and this point even, lots of people would like to tell me it's 1 over 1, but that's false. You can't count boxes. Right here, when I go up one box, look at your scale. I'm going from 2 to 4. I really went up 2. And here, when I go over one box, I am going over 1. This slope is 2 over 1, which is the same thing as 2. Take a look at the labels now. The reason why we call it a rate of change a lot of times is because of real life situations. So this is about the price of apples and the rate at which your cost changes in comparison to how many pounds of apples you buy. So if we go back to this 2 over 1 and put our units, 2 is the cost, while 1 is the number of pounds of apples. So it's actually telling me that my cost increases $2 per pound of apple, per 1 pound of apple. So it is a rate at which something is changing. It's a rate at which your cost is changing. And it depends on your number of pounds of apples. So in science class, I think you've learned about your independent and dependent variables, and that's what this graph is about. Because remember, when we take a test, it's all going to be about like realistic types of problems, our word problems. So we do have to be able to relate it to real life situations. But I feel like I'm done. This is just extra practice. I'll have like the answers in Google Classroom, but your homework is on this page. And I had said you only have to do the odd numbers. So it's finding the slope given this information. Oh, you know what? These bottom questions, I want you to think really hard about. There is one question similar to it in this classwork someplace, right here. I'm going to do this one real fast before I let you go do your homework. So a line contains points x, comma 4 and 2, comma negative 2, and it has a slope of negative 2. What's the value of x? So instead of asking you what is the slope, I gave you the slope, and I'm asking you what is like one of the missing coordinates. So if we use the slope formula that says y2 minus y1 over x2 minus x1, and you put in the important information, you'll be able to find it. So let's call this x1 and y1. Let's call this x2 and y2. And your slope, remember the letter we can use is an m. So in place of m, I'll put this negative 2. In place of y2, I'll put that negative 2. In place of y1, I'll put that 4. In place of x2, I'll put that 2. And in place of x1, I'll put that x. And now I want to make it look like, I want to simplify it. That's what I want to do. So negative 2 equals, in the numerator, negative 2 minus 4 is negative 6. In the denominator, I can't simplify because I don't know what 2 minus x is. Now, I want to make it look like a proportion. And I want to do my cross products. So negative 2 times 2 minus x will equal 1 times negative 6, which is negative 6. And we solve this equation. And I get x is negative 1. Okay, so you can just use your formula to find any missing piece of data. So I'm going to let you go now. Have a good day. Rewatch this video as many times as necessary, and I'll see you soon. See ya. Bye.